Welcome back to my rubber duck coding series. For those who haven't heard, teaching an inanimate object in front of you like a rubber duck helps you learn, and hopefully I'm bringing value to someone out there learning to code and learning to code with Java. Again, I love learning as many languages as I can: JavaScript, Python, Rust. But I started in Java, and so this is like a sort of my default playground. I've done a lot of JavaScript as well. So, and today we're going to go over what we did with quickly with hash map. We're just going to reiterate a little bit on the hash map. There's a couple of things I forgot to mention that are very important. And we're going to move into linked lists, which is surprisingly a lot more powerful than you think. So let's dive in right away. I'll do less fluff today, less philosophy, although I will spill philosophy. It's very hard for me not to spill philosophy. It's in my nature. But let's move forward with things I believe I missed on the hash map. So I just wanted to show you an example, what I think is a powerful example. I used JavaScript to build this React component, and the React component's main sort of model object that it accepts is the task model for this. It's a Trello-like board we created. Call it a task cardboard or Trello board or whatever you want to call it, but it's a whole bunch of tasks in a board of cards. And the top level object that's passed in is a map, and each map and each entry in the map represents one swim lane. So this would be index 0, 1, 2, and 3. And the value of the map is a list. And in that list, there's a card object or task card object. And each task card is an object that has a whole bunch of properties that define the task card. And if we click on the title of any one of these task cards, I added just this ability to see what the data was. The data is in the form of JSON. And you can see the different data properties of each card. If I click on another card, you'll see the card data changes. So very powerful object. If I need to create a new swim lane, I add a new entry to the map. If I need to create a new card, I add a new card to the list. And even we're talking about linked lists today. It makes sense that the list inside the map, the value of the map, is a linked list where I could easily manipulate this list. But we'll get into that in a minute. But your list implementation would be just as important. So that's an example of using a hash map. I thought it was a powerful one. There's so many out there, as I described in the last video. There's something pretty key that I missed to discuss. I'm sure there's lots of little things I've missed to discuss, and the nature of putting videos out in YouTube is everybody's going to correct you. I'd be probably scared to leave the comments on at this point, being I'm new to this, but whatever. Let's let the chips fall where they may. So I didn't discuss hash function, and it's really important to discuss because it's the concept. It's an algorithm like SHA-256, or there's different names for these other algorithms that provide math operations to do something interesting here for the hash map. It's called the hash function, and that function will take an input and give you back the exact same output every time, guaranteed contractually. That's the idea. So no matter what input you put in, if it's the same input, the exact same input, you will get the exact same output. And that function will manipulate the exact data coming in, and it will take the bytes and the numbers that it'll break everything down into bytes and numbers, and from there it'll do some bitwise operations or some bit operation, and some math operations, some calculus, some modulus operation, but it will do it repeatedly, thousands of times even, and it will output a key that is predictable. So if you pass an apple, and the result will always be this predictable key. So that's how it is able to perform the O to 1 the O to 1 operation where there's we're scaling the data set scaling the data set size has 0 impact on execution time. The key is always known. It's always known quickly, and it's not reversible. That's the point. It's not easily reversed. So that's a hash function. Hopefully I did a good job of explaining it. That's how when you put a key into the map, there's this hash function behind it. That's important to know about. So moving on, today we're going to talk about linked lists, and obviously linked lists is a concept that different languages implement. We're going to be talking about Java's implementation of the linked list. There's the concept of a singly linked list and a doubly linked list. A singly linked list is very simply it only moves in the forward direction, not in the backwards direction, if that makes sense. So here's a very simple implementation of a singly linked list example, forward only. Very simple implementation. This is not using Java's implementation, it's just something we've created on the fly. So you have a class list node with a value, which would be this value here, and it only knows about the next or forward moving position, the forward moving links. So this next is pointing to this node, and this next is pointing to that node. It moves forward only. So that's a singly linked list example. And if we run this, you can see that I've created 3 nodes, and you can consider all 3 nodes a chain, and each link in the chain is connected. So interesting. All I did here, if you just I just looped over the head of the linked list, and we called next until next was null, and we get this very simple output. So that's a singly linked list. And today I'm going to demonstrate an example of the doubly linked list, where now a little more advanced. Both of them have heads and tails, or beginning and end, and we will use the Java implementation linked list to create a playlist, a music playlist. Now, it's very easy to implement, say, a linked list. You just simply write out the constructor for the linked list and tell it what you want to store. In the real world, this would be an object like song, but I wanted to keep it as all examples do. They keep it simple, but normally you'd put a song there. Today we're just going to put the song title in the form of a string, and we're going to use this linked list to create ourselves a music playlist. So I'd like to get just to get as quickly as possible here to the implementation. In the end, once you're done, you will have a music playlist. You will add 3 songs, and we can show the playlist by iterating over it and then start playing, so kick it off, and then from there we can play next. And there's a few little subtleties I have to do my best to explain that are little gotchas if you're learning or whatever. It's Java's version of the implementation, but adding a song, very easy. We're adding a song last, which would add to the tail, and the next function we create is start playing. Now, right off the bat, you see in the start playing function, there's this iterator. Now, what the iterator does is it keeps track of the current index or the position you are in the linked list, so you don't have to do it manually. It's why, otherwise, if we didn't use the iterator, we would have to create another index ourselves, this integer, and we would have to access the playlist by saying get current index. Now, that's not fun to try to manage your own index, and the developers realize that, so they created this thing for us called the list iterator, which will iterate over the linked list. Now, so another interesting implementation of a linked list is a queue. There's a data structure out there called a queue, and queues are FIFO, meaning first in, first out. Think of a line at a coffee shop. It's the one I always go to. So you can only process the first guy in line, the first person in line. And but basically, a linked list is a queue because because the nature of a queue, where you have this first in first out, is just a contract on how to use a linked list which has already been implemented. So my point is that if you drill down into linked list in Java, and you'll see that the class implements this other interface called a deque, which extends queue. And we'll get into deque in a minute, but you can see that it extends queue. There's lots to read here, and I totally recommend you do. The point is, to implement a queue is very simple. And it's very powerful. There's a service in AWS called SQS, which you would use which is just one big queue, managed queue. And queues are powerful because it's a way to make sure that big data gets processed. That's one major real world implementation, is that you have a whole bunch of you have many objects that need business logic applied, and they're streaming in, they're flowing in, and you need to store them to get processed, but you need to process them one at a time, and so you need some kind of queue to help the line grow as you're processing the ones in the front. Basically, that's the idea. And so in Java, what we can do, a long-winded way of saying, let's get to some code here, is we can implement the queue. Let's say that the queue has a string in stored. Actually, it'd be easier just to do this, right? And notice we're just creating a linked list with the interface of queue. And now we had these functions available to us before, offer and poll, but now it's the only we're not given the functions that we don't need, and we're given the functions that we need for the queue. Here would be, we can exhaust the queue, as they would say, sort of process the items in the queue by just simply going, while the queue is not empty, continue playing these songs by polling or removing one item from the queue. So if we run that, you'll see that we played each song in the queue, and if we print out the queue once more, we'll see that it's now empty. So we processed the value, the objects in the queue. So the next object I want to discuss is called an ArrayDeque. And interestingly enough, depending on how you use it, you could use it as a stack, which is LIFO, last in, first out. Think of a stack of plates. The last plate in is the first plate off. Or you could use it as a queue where, there's this notion of line where it's first in, first out, FIFO. So it just depends on how you call the queue. But if you're going to create a stack, this is the object I would use. It used to be called stack, but now it's called a double-ended queue, which can perform either function, a stack of plates or a line of people. So it just depends how you implement it. So if I run this, you can see that we create our stack of plates by pushing 3 plates. If we peek, which means read from the top, so the top of the stack is plate 3 because it was the last one in. And if I remove from the top and then peek again to see who's on top, plate 2 is on top. And we can keep peeking to see the new top, run it. And because I never popped. We never see a change in what it's peaking at. So let's pop again and pop again. And eventually we get null because we take all the plates off. So this would be your stack of plates just by popping and peaking. Pushing and popping. Very powerful, very simple to understand, I believe. And of course, underneath, here's the implementation of how you use a queue. So if you pull first, so you pull from the tail, sort of the head, I guess, the first in line. That's what you want to think about. It's the first one, first in line. Then you would be serving the first person in line, person A. So the first person in line is A, and when you pull first, you pull from that side of the queue. You pull from the start of the queue. So I hope that helps. So today, so today I hope I helped you demystify linked list. I helped. We went over queue, and you saw how there's an actual queue interface for the linked list implementation, and we sort of demystified ArrayDeque, that is used for stacks, like a stack of plates stands for double-ended queue, and you can add and remove from both ends efficiently. That's why it can work for a stack or a queue depending on how you use it. So that was a lot of fun. That was interesting. I hope somebody out there learned something off this. I know I will go back to this to learn something, and we'll get on to the next one. Short and sweet. I'll get on to the next one. I appreciate. I hope you learned something. Let's start that over. So in summary, linked list is very powerful. If you need to move forward or backward, like a music playlist, that's the object you go to. If you need things linked in a chain, or if you need the idea of a train with train cars and they're all linked, think that's an obviously good analogy to make. Train cars are linked together, and so you can use the queue interface with linked list for simple FIFO behavior, but for better performance. And most people these days are using the ArrayDeque because a double-ended queue, the interface is called DQ, is really the standard for modern performance. And if you have a reason to code a new queue or stack, you would use the ArrayDeque. So I hope this is practical advice. Thanks for watching. I hope I brought some value to, and we're on to the next one.